The E3D Revo High Flow nozzle is sort of a solution to a problem that E3D created themselves. It's typically what Apple would do, but this isn't in fact a bad ecosystem or a bad product. But the core issue with these is, of course, the Revo ecosystem uses nozzles that are all the exact same length, which makes for easy swapping. You take out one nozzle size, you plop in another one, you don't have to reset your Z height, there's no extra mass, extra PID values that you have to tune for a bigger heater block or anything. It's just a really quick and easy quick swap system. Whereas there was the option in the previous V6 ecosystem to just use a longer heater block and a longer nozzle called the Volcano to basically increase the length that your filament was in contact with the hot heater block and the nozzle. There is no space in the Revo to add more material. Slice Engineering did something smart here because they had the space with the Mosquito and the Mosquito Magnum, where they just went up. So they added a bit of extra copper and an extra heat shield towards the top because they have the space there. But of course, on Revo, there is no space to be had. So really the only option they had was to make more use of the space they were using. So this wasn't something that E3D was solving so far, and because this nozzle brake design is a patented, protected, proprietary design, nobody else was able to make custom nozzles. And the high flow nozzle is not a third-party design. This is a genuine E3D nozzle. So what is the solution that they came up with in this new patented proprietary everything world? Of course, it is more patents. It's licensing the Bondtech CHT design. So if this interior design looks similar to what you've seen with the CHT, which is I don't have one, but it's a V6 style nozzle that has 3 extra bores, this is the same thing. It's the same IP, it's just in a different package. Patents and proprietary designs and, making sure that nobody else can produce stuff for your system, that is a topic for its own entire video, and I think I'll be working on that next. But today, I just want to focus on the actual performance of the Revo High Flow nozzle. Right after a message from today's sponsor, Skillshare. Are you ready to take your career to new heights? Whether you're a self-taught learner, a career changer, or an ongoing side hustler, Skillshare has got you covered. Skillshare offers classes that you can take at your own pace, that are professionally hosted and edited, and come with a helpful community to discuss ideas and questions that come up. You've seen me and others recommend Skillshare classes about learning video editing, time management, and diversifying your income. But by joining Skillshare, you can start exploring any topic that interests you and find a course to give you a kickstart. I've taken a liking to vegetable gardening this year, and even there, Skillshare has the whole range of classes that have you covered from starting this relaxing hobby to going all in with a hydroponic setup. Of course, I've also used Skillshare classes for brushing up on skills that are useful for this channel. Both soft skills like how to efficiently organize a business and hard skills like learning a bit of graphics design that comes in ever so helpful every now and then. And here's the best part, you can join in too. Skillshare is offering a 1-month free trial for the first 1,000 people to use this link. It's an opportunity to redefine work, chase your dreams, and achieve new goals. Sign up now and be part of the Skillshare community. Thanks again to Skillshare for sponsoring this video. So in this entire 3D printing bubble, we are at a point where it doesn't cut it anymore to just chuck a product in a printer and say, yeah, this works, this prints, cool. No. There is way too much competition between media outlets, YouTube channels even, that you really have to offer something special to get any attention on the content you make. The E3D did a bit of a better job releasing the Revo High Flow, but we didn't really get these much before the products were actually available and were shipping. So yes, this is something that E3D did provide for this review. No payments, no money changed hands, and they, of course, didn't see the video script or anything before this goes live. But yeah, to offer something special, I built a fancy, totally automated pot-end extruder nozzle test setup to specifically test the Revo High Flow nozzle. This you will have seen in a slightly different state in the original Revo review, but now this is automated and data logged and quite a bit better. But first, what is the Revo High Flow nozzle? So it's a two-part design, similar to the Obsidian. there are 3 bores in the nozzle instead of 1, which increases the surface area that the filament is in contact with the actual heated brass outside portion of the nozzle. And of course, to manufacture this, they pressed in that 3-bore part into the nozzle brake housing, pretty much the same way as they did with obsidian. Now, this is not a new idea. In fact, I think at TCT it was over 5 years ago now. I've openly discussed some different approaches to doing exactly this. I suggested maybe you could have a split nozzle that you machine the inside and then kind of reassemble it somehow, or you use some extruded sort of radial heatsink style thing and press it in. So this, of course, is the result of making it machinable, making it somewhat easy to produce on a CNC lathe milling machining center. And you get the insert part, you get the slug, and of course the rest of the nozzle, and you just press them together and they fit in place with pretty tight tolerances, and you get your finished dimensions with, not much to go wrong. That jet spike that you're seeing on the inside of the design seems to serve 2 purposes. Of course, it reduces the amount of molten material that is inside of the nozzle here, but it also probably improves fluid flow because it kind of looks like a jet spike. You probably want a more laminar flow across this thing, reduces drag, and just makes for a better performance overall. So this is now a 4-part nozzle, 5 if you count the silicone sock too, in the same way that obsidian is a 4 or 5-part nozzle. So this retails at 40 British pounds directly from E3D. Obsidian is about 50. Regular Revo nozzles are 20 pounds and V6 nozzles are 5 pounds. So this Revo High Flow nozzle is 8 times as much as the classic V6 nozzle. For comparison, a V6 CHT nozzle is about 24 euros, so the math does check out. 20 bucks extra for the CHT tech, 15 bucks extra for Revo, and yeah, it works out to about 40 pounds for this setup. It's an expensive nozzle, right? So is it worth it? To find out, I reworked the tester that I originally built for the Revo launch. It's automated now. Now the hot end is mounted directly to this beam through a load cell, and if you look at the scale right there, as I push down on the hot end as the extruder would when it pushes filament in, we actually get a real-time reading from that. So I wrote a quick and dirty little Python program that actually connects to both the main board as well as the ESP32 running the load cell. The main board is going to run the extruder, it's going to extrude a certain amount, and while that is running, while that is happening, we're also reading the ESP32. Okay, so here's one thing that I caught just in time. I was wondering about my data, like why was it getting these random drops in extrusion force? That shouldn't be something that's happening. Which is the point when I remembered, hey, this E3D Hermes, this is one of the early ones, and the early ones have an issue where the gear was cracking, and I guess what I was seeing there with the random drops was literally the gear skipping or slipping on the motor shaft. So I opened this up, and lo and behold, this gear was cracked. So I grabbed the new one. They sent me this one for the Revo test. This actually has the little spring clip at the bottom where it connects to the hot end or where the heater would mount, but I can use it just the same with the bone adapter. And this one I just made sure to check. This one does have a gear that is properly pressed and functioning, and yeah, I'm gonna put this one in and then we're ready to go, finally. So yeah, the original plan was to just have the Python interface and to enter my values for each test run, hit go, it would do its one run, and then I'd hit go again, it would write it to a database. Yeah, I did end up completely automating it, so I would just have to install one hot end and it would do all the heat up, cool down, temperatures, the different flow rates. It would run 3 of each. Just did a lot to speed up and streamline this process. I tested all 0.6mm nozzles. So the High Flow, of course, is a 0.6, the regular Revo, the V6 and the Volcano V6, all 0.6. I only ran PLA. This is some blue Torwell PLA, just standard stuff. And I do have my flow measurements in millimeters per second, so linear extruder speed in millimeters per second. I tested 2, 5, and 10 millimeters per second, which works out to about 5, 12, and 24 cubic millimeters per second as far as flow rate is concerned. For reference, full throttle on a regular 0.6mm nozzle and 0.4mm layers on a Mark III, that tops out at about 15 cubic millimeters a second. So I'm testing both lower and higher than what you're seeing in a typical slow printer even. Of course, once you add input shaping, those numbers can go up quite dramatically, but there is, we're going to discuss that in a bit, there is a limit to how much flow makes sense for a nozzle. There is some optimal combinations somewhere, but you can't expect to use a large nozzle, large layer heights, and fast speed. So it's a pick two sort of situation. The assumption I'm making for all this testing is that the resistance that we're measuring, because all I'm doing is I'm measuring the force that the extruder is pushing the filament into the hot end with, it's that force is basically being generated at the nozzle bore itself. So the more thoroughly the filament in the nozzle gets heated, the more readily and the more easily it will flow through the nozzle bore itself. If you have a nozzle that has a higher flow rate or a better melting performance, it's also going to be easier to push at the same speed, at the same flow rate. E3D also did publish some testing for maximum flow rates for their various nozzles, but the thing I'm missing there is that they aren't specifying what their cutoff, their limit criteria is for, you know, what is the maximum, what works, what doesn't. The thing is, if you push harder, at some point you're going to get more flow. There's no hard limit in theory. There is a very practical limit though. So with this E3D Chimera, there is a limit to where it's going to slip on the filament, where the actual gears are going to slip on the filament. I've got this cranked all the way tight, the spring is at its maximum pre-tension, and all I got out of this was about 10 kilogram before it slipped. Simple extruders that only grab on one side, they're going to have a lower limit. 10 kilograms of force on the relatively thin 1.75mm filament puts PLA at about half its datasheet yield strength. What is totally plausible is that because the gears are just gripping on the side, we are actually shaving off or shearing off the filament. We're mechanically damaging it in the extruder itself. So it's not the gears kind of skipping over the teeth that it's grinding or pushing into the filament. It is literally the filament not being able to take any more force before it breaks apart. That would be a hard limit, at least for this type of extruder. The data I'm getting out of this is basically the force that it takes over a 100mm extrusion move. What we can see, so this is just an example graph here, what we can see at the start is as the hot end is empty, there's almost no force, but the filament inside the hot end starts flowing, and then at some point it slams into the nozzle. And there is always that spike at the beginning. I don't know if this is like aerated, bubbly, or just boiled old material being a bit harder to push, but that spike is always there. Then you get a portion of almost a consistent but lower force as the hot end is basically pushing out its pre-molten material. So there is a certain volume of material inside the hot side of the hot end, and that basically is assumingly at the exact perfect temperature, so 210 degrees Celsius, that will be thoroughly, completely heated. So low force there. And then eventually, as we get to filament that has made it all the way through the hot side now, we do get an increase in force required, because this is not going to be heated as thoroughly as the material that was already in there. And eventually we do end up at a sort of steady state extrusion rate, or force at a certain extrusion rate for this nozzle. This entire testing thing does generate a lot of data. And in fact, if I were just to like manually look at data points, it would be too much to make sense of. I used about 23,000 data points, and I probably did end up throwing out another 50,000 because I ended up redoing tests. I ended up doing them slightly differently. I double checked them for consistency. So yeah, we will get a sum up of the core data in a bit. But before we do that, I want to show you two sort of distinct testing sequences that stood out to me. The first ones are failed tests, where you can see the skips in the extruder. These only happened at the full 10 millimeters per second, so 24 cubic millimeters per second. Here, basically, the pre-molten filament gets pushed out, all is fine, but as soon as it hits that fresh filament that has made it through the hot side, we just get noise. The load cell is reading accurate data, but because the force is jumping around so much, it's basically random points. This is the Revo High Flow at 10 millimeters per second. And what we're seeing here is sort of a pulsating, a waviness in the force required, a waviness in the force required to push the filament. I have no idea where this is coming from. It's rhythmically and repeatedly going up and down. Like it's extruding fine, it's working fine, but there is something fluid dynamics wise happening. I don't know if this is buffeting inside the nozzle geometry, or just a mechanical effect from the extruder pinching the filament in some way. I don't know. It's there, didn't matter much. I did average out the values, but just something to note. If you're seeing something similar where your extruder is making funny noises if you're printing fast with a high flow nozzle, leave me a comment below. That would be very interesting. In fact, while doing these testing runs, I realized there is so much more data to be had with automated testing. I could map temperature versus flow resistance. I could do maximum flow rate against available extruder force. Of course, I could also test extruders themselves. That is sort of planned here. There's just so much potential here. But yeah, let's get to the summary of what I found. The first interesting thing that I found was that the V6 and the V6 Volcano had much lower forces overall, as long as it was extruding well and didn't skip. Especially at 210 degrees, it is very noticeable where, of course, we're not seeing a whole lot of force at the 2 millimeters per second feed rate, but that is something that was not consistent with my initial Revo tests that were done with a 0.4 millimeter nozzle. This is just something to note. The ultimate performance didn't change from this, but it's interesting. Without a temperature bump, remember this is all done at 210 and then a separate set of tests at 230. Without a temperature bump, the Revo High Flow was the only nozzle that could do 24 cubic millimeters a second. All the other nozzles required a bump to 230 degrees Celsius. The V6 could never do it, just a stock V6 with the short nozzles. Couldn't do 24 cubic millimeters a second, and the stock Revo, so the non-high flow version, but the Revo, did have significantly higher forces required to push PLA at that speed at 230 degrees Celsius. Now, of course, you don't want to bump temperatures if you can avoid it. It just makes for a less consistent extrusion. If you print slower, then the filament has more time to cook and to fully heat soak, so it's going to be much more liquid. It's going to be tough to print with higher temperatures because you're compensating for something that you can't really compensate for with temperature. You really need that extra thorough heating, which you're not going to get consistently by just bumping the temperature. Otherwise, there isn't much difference between the stock Revo and the Revo High Flow in normal or lower speeds. Yeah, this isn't a downside or an advantage either way until you get into the higher flow rates. You don't need any improvement where stuff already works, and it is good to see that the high flow insert doesn't add any extra drag to the extrusion path. That would be a step in the wrong direction. One thing I should maybe also note is that there is a slightly different approach in extrusion with the CHT or the high flow design versus volcano style or super volcano or Magnum designs. And that is that the volcano, Magnum Plus, super volcanoes, they just have a larger reservoir, a larger buffer of preheated filament that they can tap into. You push fresh filament into it and it empties that buffer first. And once that buffer is empty, yeah, you do get a slightly higher extrusion or melting rate. In typical printing, it does work pretty well because you're never going to have, or rarely going to have, like a super high flow constant load. Unless you're doing solid infill. In that case, yeah, that's going to be a limiting factor. Revo High Flow and CHT, on the other hand, they have basically the same amount of pre-molten filament volume as a V6 or a regular Revo nozzle. But the High Flow and CHT, they aim to then continuously provide more melting rate as you go. And with that insert, of course, a more thorough and well-mixed melting experience. That makes, I think, for a cleaner and better approach. Volcano, super volcano always had a bit of an issue with oozing because you just have so much material cooking away. It's also better for filament degradation, of course. Again, lower temperatures, more better. It does require a quicker heater tune on the Revo, especially because the Revo heater cores have such low thermal mass. They're very small compared to a volcano or even a V6. Like, they have very little thermal mass. But in general, that is a approach that I very much like. It's in similar vein as the feed-forward systems like input shaping or pressure advance, where you rely on software to compensate for known limitations or known properties of a thermal or mechanical system, instead of just overbuilding that system so you can have your slow or imprecise control system doing its thing and not have to worry about. This is the more modern, the more elegant approach. On the note of heaters, I did not use the new 60-watt heater that they did supply with this hot end, or with the nozzle. I didn't use that. I kept to the 30-watt heater for both the Revo and V6 and Volcano just to keep things fair. I don't think you need the higher heating power unless you push it to the absolute limit, but at that point you're going to run into other limits first, namely your extruder or motion system. Overall, the Revo High Flow now provides, with the 0.6, a slightly superior experience to Volcano. The Revo, in my initial testing, the 0.4 was slightly worse than Volcano. This is now slightly better. Now, of course, the question is, do you need one? And the answer is simple, probably not. For 40 bucks, I mean, yeah, sure, Revo is already an expensive ecosystem to buy into, so you might as well. And it's the only option for higher flow if you're already invested in the Revo ecosystem. There's simply no alternative. It does make sense if you want to use Revo in a faster motion system, and if you're buying new nozzles anyway, you might as well get the high flow version. If you're building a Voron, or if you're upgrading, I don't know, any of the other Core XY systems to a Revo, then this might be a good option if you really want to push speeds. Otherwise, like I said, if you aren't running into limitations with your current setup, you don't need to upgrade to a high flow nozzle. Hope this was helpful. As always, thank you for watching. Thank you to everyone who is supporting the channel through Patreon or YouTube memberships. More info on that on screen somewhere here. But for everyone, keep on making, and I will see you in the next one.